Hi guys, welcome back to my YouTube channel. To those who don't know me yet, I am Erma Joy Novela, and for today's video, I'm gonna discuss to you the physics, specifically the kinematics, which deals with the quantitative description of motion. And we have four to solve or get, which are the distance, displacement, speed, and the velocity. Anyways, we're gonna define them first. First is the distance. Distance refers to the actual length of path taken by an object that is moving from its initial position to its final position. Next is the displacement. So what is displacement? Displacement refers to the actual measure of the difference between the initial position up to the final position. Third is speed. Speed is defined on how fast something is moving or how much distance is covered in a certain amount of time. And lastly, the velocity. Velocity is defined as the rate of change of displacement. For your information, before we proceed to solving, is that distance and speed are scalar quantity which they have no direction, and displacement and velocity are vector quantity which they have direction. So you would know them further as we start solving. Let's have the distance and displacement. Problem number 1. Emma walks 150 meters north to visit her grandma and then walks 60 meters west to buy snacks. Find the total distance traveled by Emma and her total displacement. So first, we're gonna get the distance. So let's have capital letter D represented by distance. So let's just add 150 meters and 60 meters. 150 meters plus 60 meters. So that's equal to 210 meters. So that's our distance. So that's the distance traveled by Emma. Next question is the total displacement of Emma. So let's have small letter D as we solve for displacement. Since they have different direction, so we will use the Pythagorean theorem. So we would make the illustration first. So Emma walks 150 meters north. So north 150 meters, and then 60 meters west. 60 meters. So the displacement is here from its initial position to the final position. So let's have the Pythagorean theorem. So c squared is equals to a squared plus b squared. So let's have 50 meters as the A and the 60 meters as the B. So c squared is equals to 150 squared plus 60 squared. That is equals to 26,100. So let's have the square root to cancel the square. So cancel. So C is equals to 161.55. Let's have the unit meter. Let's have the direction. So northwest. So our total displacement for Emma is 161.55 meters northwest. Problem number 2. Malin and her best friend walked 2 kilometers north from Malin's house, then covered 3 kilometers more due east to find the signal. What is the total distance of Malin and her best friend and their total displacement from the starting point? So let's first get the distance as usual. D is equals to, let's add 2 kilometers and 3 kilometers. 2 kilometers plus 3 kilometers. That's total of 5 kilometers. So the distance covered by Malin and her best friend is 5 kilometers. And let's have the displacement. Let's illustrate first their displacement. So 2 kilometers north, 2 km, and then 3 kilometers west, east. So their displacement is from here, initial point to final position. Let's have the Pythagorean theorem again. So c squared is equals to a squared plus b squared is equals to, let's have 3 kilometers as A and B here. A squared is equals to 3 squared plus 2 squared. So 3 times 3 is equals to 9 plus 2 times 2 is equals to 4. So we have here 9 plus 4 is equals to 13. So c squared. Let's have the square root to cancel the square root. So square root of 13 is 3.61. That's rounded off, guys. So that's the total displacement of Malin and her best friend. The direction, guys, is from north to east. So let's have here north, east. The total displacement of Malin and her best friend is 3.6 kilometers northeast. So that's problem number 2. Lastly, for distance and displacement, let's have problem number 3. An object moves along a square with 7 meters all sides. That meant goes back to its original position. Find the distance and displacement. So let's have first the distance. D is equals to, let's add 7 meters. 7 meters plus 7 meters plus 7 meters plus 7 meters, because the square has its 4 sides. So that's equals to 28 meters. So the distance of an object that moves along the square is 28 meters. Let's then have the displacement. So here in the problem, it states there that man goes back to its original position. So remember, in displacement, if the path is curved and go back to its original position, it is automatically, the displacement is 0. Let's then go in solving the speed. So problem number 1, a van travels a distance of 20 kilometers in 12 minutes. Find the speed of the van within kilometers per hour. So the formula of the speed is S is equals to D divided by time. So D here is distance. So the distance, the given distance is 20 kilometers. So it states here in the problem that within kilometers per hour. So we have 12 minutes here. So let's have the conversion first. So divided by 12 minutes. So let's convert 12 minutes to an hour by dividing 12 over 60. So 12 divided by 60 is equals to 0. That's 0.2 hour. So let's then divide 20 kilometers divided by 0.2 hour. So speed is equals to 100 kilometers per hour. So that's the speed of the van. Let's then go to problem number 2. Marie walked from their house to the mall with a distance of 70 meters in 35 minutes and then had ride a car to the municipality with a distance of 80 meters in 5 minutes. What is Marie's average speed? Let's have the formula. S is equals to distance divided by time. So S is equals to distance is 70 meters plus 80 meters here, 80 meters, and then divided by time, 35 minutes plus 5 minutes. So let's minutes. So let's add firstly 70 plus 80. So we'll have 160. We'll have 150 meters divided by, we'll add 35 plus 5 is equals to 40 minutes. So next step is we would convert meters to kilometers and then minutes to hour. If we have 1000 meters, so that's equivalent to 1 kilometer. So let's divide 150 divided by 1000 in order for us to get the kilometers. So that's equals to 0.15 kilometers divided by, so let's convert 40 minutes to hour. So 40 divided by 60 is equals to 0.67 hour. So let's divide 0.15 kilometers divided by 0.6 hour. That equals to 0.25 kilometers per hour. So that is our speed. So Marie's average speed is 0.25 kilometers per hour. Lastly, for speed is a bike's average speed for a 20 kilometers trip is 5 kilometers per hour. So how long did the travel did? So as you observe, guys, we solved for this speed a while ago, And then right now we would gonna find the time. The formula in getting the time is the T is equals to T divided by S. So that's distance divided by speed. So T is equals to, how much is our distance? We have 20 kilometers divided by 5 kilometers per hour. Let's then cancel and then cancel. So that is equals to 4 hours. So that is the last problem for the speed. Lastly, we will solve for the velocity. Problem number 1. A plane is heading due north at 12 kilometers per hour in a wind moving 7 kilometers per hour eastward. Determine the resultant velocity of the plane. So, in this problem, we have different directions. Let's illustrate it first. So, 12 kilometers per hour north, 12 km per hour. And then 7 kilometers per hour eastward, 7 kilometers per hour. Here is the initial position to final position. So let's apply the Pythagorean theorem. So A here, B here, and C. So C squared equals A squared plus B squared is equal to C squared is equals to A7 squared plus 12 squared. So C squared is equals to 7 times 7 equals 49, and then plus 12 equals 144. So C squared is equals to 49 plus 144 is equals to 193. So that is kilometers per, let's apply the square root first because there is still a square. So C is equals to 13.90 kilometers per hour. And that's, our direction is from north to east. So let's have northeast. Northeast. Next is problem number 2. A ship is heading due to south at 70 meters per second in a tide moving 30 minutes per second due west. What is the ship's resultant velocity? First, we will illustrate it. So, 70 meters per second south, 70 meters per second, and then 30 meters per second west, 30 meters per second. Let's apply the Pythagorean theorem. C squared, because the initial point is, we will have 30 meters per second here, 30 meters per second, because our initial point or position is here, and then to final position, which is here. So C known. So C squared is equals to A squared plus B squared. So C squared is equals to A, we have A here, B here, 30 squared plus 70 squared. C squared is equals to 30 times 30 is equals to 900. plus 70 plus 70 times 70 is equals to 4,900. So let's add it to 900 plus 4,900 is equals to 5,800. So let's have the square root to cancel the square. Cancel. C is equals to 76.16. 76.16. So our unit here is meters per second, and the direction is southwest. So that is our resultant velocity in the problem number 2. Last but not the least is the problem number 3 for the velocity. Current travels a distance of 45 kilometers from Lapu-Lapu City to Cebu City in 25 minutes to have some appointment to a client. After an appointment, he went back to Lapu-Lapu City with a distance of 45 kilometers in 1 hour. What is current's average velocity in kilometers per hour? So the formula of the velocity is V is equals to displacement divided by time. So let's determine first the displacement. As in here in the problem, it states here that she went back to Lapu-Lapu City. So eventually she goes back to her original position. So automatically our displacement here is 0. So whatever the time is, so let's have 0.42 hour plus 1 hour. Whatever the time that will divide the displacement, if the displacement is 0, the answer is 0. So our average velocity here is 0. And we're all done with all the problems. That's all, guys. Hope you learned a lot from this video and hope to see you again in my next vlog. Thank you for watching and God bless.